All right, hey there guys. My name is Wilfrid and I'm a senior math tutor. And today I'll be covering 9 questions related to functions and algebra. So a little backstory about myself. I graduated from McMaster with a major in biochemistry and a minor in mathematics. And if you have any other problems or questions related to chemistry, calculus, mathematics, algebra, just send them through OneClass and we'll get to them as soon as possible. But other than that, let's begin. Okay, so the first question reads, write log base of 8 of 3 as a logarithm of base 5. Okay, so there's a lot of different properties of, where did my question go? There's a lot of different properties of logarithms, and one of them is the change of base formula. Okay, so the change of base formula suggests that it suggests that a log of base, let's say b of x, can be changed to log of base a over by using this formula. Okay, so it's the log of base a of x divided by the log of base um, a of b. Okay, so by doing this formula here, you'll be able to get the log of base a of x. Okay, so that's how you change your base, and we're going to be using this formula for our example here. Okay. So we have on our example that we have the log of base 8 of 3, and we wanted to change it to the log of base 5 of 3. Okay, so we're going to use the formula here to calculate and how to change this base. Okay, so as you can see here in the formula, we take the log of the new base and of our current argument divided by the log of our new base and of the old, and the argument is of their old base. So that's what we're going to do here. So that the log of base 8 of 3 is equal to the log of base 5, which is our new base, of our argument, which is 3, divided by the log of our new base, with the argument being our old base, which is 8. Okay? And by doing that, we have now calculated what log of base 5 of 3 is. And if we can use a calculator here, we can confirm that. Okay, so what I'm going to do now, I'm just going to calculate the log of base 5 of 3. This calculator doesn't calculate different bases. Well, let me just use a calculator here. So actually, I'm not gonna use a calculator here. I'm just going to say that the answer is log of base 5 of 3 is using this formula. So you change the base by using this. And that's what the junior tutor wrote here. So the solution is correct. Okay, moving along to question number 2. Okay, so the question number 2 reads, how do you factor x cubed plus 8? Okay, so we're going to use a technique called the sum of 2 cubes to evaluate or to factor x cubed plus 8. Okay, and so the sum of 2 cubes tells us that the sum of 2 cubes with a cubed plus b cubed can be factored as such: a plus b times a squared minus ab plus b squared. Okay, so the converse of this is, or the alternative one is the sum of the difference of 2 cubes, or the difference of 2 cubes, and we have the difference of 2 cubes here, and that is equal to a minus b times a squared plus ab plus b squared. Okay, so whenever you're using these two, rules, you have to recognize that your example here is the sum or difference of two cubes. Okay, so x cubed plus 8 can alternatively be written as x cubed plus 2 cubed. And by looking at this, we can use the sum of two cubes to factor this into x plus 2 times x squared plus 2x plus 4. Okay, oh, minus, sorry. All right, but we can factor this further, and that's what the junior tutor did. So you can only factor this further if you consider imaginary numbers or complex numbers to be part of your set here. Okay, and this is because this trinomial here does not have any real solutions or real zeros, but actually has imaginary zeros instead. So in our answer here provided by the junior tutor, they also considered that there would be imaginary roots, and they further factored down our trinomial here. Okay, so the quadratic formula is going to be used here, and the quadratic formula states that the zeros of a quadratic function can be found by calculating this formula, which is negative b plus or minus the root of b squared minus 4ac divided by 2a, where a, b, and c are the coefficients of our trinomial here. Okay, so we're going to use this in our example. So x equals negative b, which is negative times negative 2 plus or minus negative 2 squared minus 4 times 1 times 4 divided by 2a, which is just 2. Okay, and what we get here is that we get 2 plus or minus 4 minus 16, which is going to be plus or minus root of negative 12 divided by 2a. So as you can see here, that you can't square root negative numbers unless you consider imaginary numbers. So we're going to state that here. So I is equal to the square root of negative 1, and therefore 2 plus or minus root negative 12 can also be the 12 times I divided by 2. Okay. And now we're going to make this into radical form. So 2 plus or minus 2 of root 3 of I is divided by 2. And therefore, our zeros are 2 plus 2I root 3 divided by 2, and 2 minus 2I root 3 divided by 2. Okay, so now that we have found our imaginary zeros, or our solutions, we can plug it into our factored form here. So our factored form, therefore, the factored form is going to be x plus 2 times x minus 2 plus 2I over times root 3 divided by 2, and times x plus x plus 2 these should both be plus 2 plus minus 2I root 3 divided by 2. Okay, right. So this is the entire factored form. Okay. So in the junior tutor solution, they remove the 2 from the denominator. That's not necessary here. But these two solutions are correct. And the only reason why we consider the imaginary roots is because the junior tutor included in the solutions. Usually when you're trying to factor the sum of cubes or difference of cubes, you usually don't actually consider the imaginary roots. You actually stop at this step here. Okay. So other than that, the solution is correct. Okay, so let's talk about our factoring question. And the next one reads, how do you factor x squared plus x minus 12? Okay, so in the last question, we covered the quadratic formula and how the quadratic formula is used to find the zeros or the solutions, and also implicitly how to find the factored form of a quadratic function. The problem with the quadratic formula is that it's kind of tedious to use for computations, and it's actually really reserved for when you're not able to actually factor it directly. So in this question here, we're going to try to factor our quadratic function directly. Okay. So I like to call this the cross multiplication method. So basically, if you have a quadratic function, let's say ax squared plus bx plus c, you can factor it into the form dx plus e times fx plus g, where d and f are factors of a, and where e and g are factors of c. Okay, so you can factor you can directly factor it using the cross multiplication method if and only if b is equal to d times g plus e times f. Okay, so the coefficients here can be factored into the factor form, with d and f being the factors of a and e and g being the factors of c, if and only if the coefficient b is equal to the product of d times g and summed with the product of e times f. Okay, so that's how you find the factored form, and I'll go into a little bit more detail than what it means by cross multiplication. Okay, so here's our quadratic function, x squared plus x minus 12. Okay, so the first thing that we want to do is we want to think of the factors of x squared and also of negative 12. Okay, so the factors of x squared is basically 1 and 1. It also can be negative 1 and 1. So let's just write it in this form instead. So factors for x squared is 1 and 1 or negative 1 and 1. And these are not coordinates. These are just the factors, okay? The factors of 12 or negative 12 can be 2, 6, negative 2, 6. The other way, it could be 2, negative 6. It could be, whoops, this one should not be here. It could be negative 1 and 12. It could be 1 and negative 12. It can also be 3 and negative 4. And it can also be negative 3 and 4. Okay, so these are the different factors and the factored pairs of x squared and negative 12. Okay, so we need to pick one of these pairs from the x squared and one of these pairs from negative 12. Okay, so I'm going to pick 1 and 1. And I'm going to pick negative 3 and 4. Okay, so this is where the cross multiplication method comes in, where we're going to cross multiply these two digits. So we're going to cross multiply 1 and 4 and 1 and negative 3. And once we cross multiply them, we're going to add them together. And if they are equal to the coefficient of the middle term, then sorry, I'm streaming right now. Sorry, give me a minute. Okay, sorry about that. Sorry about the interruption. So where was I? So I was talking about the cross multiplication of these two pairs of factors. And if you cross multiply them and add them together, and you get your middle coefficient, then you have found the pair of factors that contribute to your factored form. Okay? And last thing to note is that the order of how you cross multiply them matters, right? So I could have put 4 at the top and negative 3 at the bottom, and it would still give me the right answer. But there are some quadratic functions where the order of these of your factored pair matters. and hopefully in the future lessons I can show that, but we're going to continue moving on here, okay? So once that you have found your proper factors and you put them in the right order, then this is your first term, and this is your second term. So this is your first bracket of factors, and this is your second bracket of factors. So now we can write out the factored form, which is going to be x minus 3 times x plus 4, okay? So that's how you factor this quadratic function, and this is the entire method of doing so. In the future, if you continue to do more practice, you can really efficiently do all these steps in your head, and you can come up with a cross multiplication. And I would just suggest that for factoring, just know the factors of different numbers. The common ones, I would say, just know your factors all the way up to the digit number 12. And if you to do that, then you're able to factor a lot of different quadratic functions. Okay, but other than that, the solution is correct, and we can move on. Okay. So the next question reads, how do you find the value of f of 5 if the function is equal to negative 2x squared plus 2x minus 3? Sorry, this is not the right answer. Okay, so I'm just going to get rid of this for now. All right, so how do you find the value of f of 5 if the function is equal to negative 2x squared plus 2x minus 3? So this is a really simple question. So given that our function is equal to this quadratic function, they just ask us to evaluate f of 5, okay? So to evaluate f of 5, all I have to do is plug in 5 where your x values are. So that'll be where x squared is, and where this x is, and the last term does not have x, it's just a constant here. So this would equal to negative 2 times 25 plus 10 minus 3, okay? And so negative 2 times 25 is negative 50 plus 10 minus 3, and we have negative 40, negative 43. Okay, so that's the answer to this question. The junior tutor wrote something different. I don't know why they wrote f of 3 in the end, but the solution is correct. You just stated the value for f of 3 instead of f of 5. Okay. Is even correct? Negative 18 plus 6, negative 12. So this is not even correct either. But other than that, they did evaluate f of 5, so we'll give them the correct answer here. Okay. All right, so now we're going to talk about this other question here. So the question reads, which expression is equivalent to 6x squared minus 19x minus 5? And they give us the factored forms of different quadratic functions. So when you're expanding from the factored form, they like to use the method called FOIL. So let's say that you had a factored form in this form, like ax plus b times cx plus d. So the FOIL method is basically an outlined algorithm of how to expand this, which tells us to multiply the first terms in each of the brackets, the outside terms, the inside terms, and the last terms, okay? So when they're asking us to multiply the first terms, they're asking us to multiply the first terms in each of the brackets. For the outside and the inside terms, they're talking about, if you're thinking about this in distance related to each other, the inside terms are the ones that are inside, are on the inside of the brackets, and the outside terms are the one on the outside of the brackets. So more medial, so more radial, more medial, okay? So the outside terms are A and D, and your inside terms are B and C. And your last terms are going to be the last terms in your bracket. Okay, so the first terms are going to be ax times cx. The outside terms are going to be ax times d. Your inside terms are going to be b times cx, and your last term is b times d. Okay. So in our question here, we're going to expand each of these options and see which one equals to our expanded form here. Okay. So let's talk about option A first, which is 2x minus 11 times 3x minus 5. Okay. So the first terms is going to be 2x times 3x, okay, plus the outside terms is going to be 2x times negative 5, plus the inside terms is going to be negative 11 times 3x, and then plus the outside terms, which is going to be negative 11 times negative 5. Okay, so if we were to calculate all the products of these, it'll be 6x squared plus negative 10x plus negative 33x plus 55. Okay, and if we simplify this, we got 6x squared minus 43x plus 55. Okay, so using the FOIL method, we multiply the first terms, the outside terms, the inside terms, and the last terms together. And then after that, we added them all together and we simplified to get our expanded form, and that is now equivalent to our quadratic function here. So we can move on to the next option here. And I guess another thing that I want to cover while I'm going through this is that you guys don't need to do it in the order that they mentioned, which is first, outside, inside, last. You can do it in any order that you want. And hopefully the goal is by having enough practice, you don't even need to use the FOIL form, and you can really just do this mentally in your head. Okay, so I'll do the FOIL form here again, which is going to be 6x squared minus 10x plus 33x minus 55. So you guys can pause the video and you guys can do the FOIL form and simplify them together. But this is equal to 6x squared plus 23x minus 55, and that is not equivalent to our quadratic function, so we have to move on again. So next one is going to be 6x minus 11 times x minus 5, okay, and that's equal to 6x squared times negative 30, negative 41x plus 55. And that is not the correct answer, so we have to evaluate the last option here. So D reads 6x plus 11 times x minus 5. What do we get here? So I'm just going to FOIL it out again. So 6x times x plus outside terms 6x times negative 5 plus 11 times x plus 11 times negative 5. Okay. So if we simplify this, we got 6x squared minus 30x plus 11x minus 55. Okay. And if we were to simplify it further, we got 6x squared minus 19x minus 55. Okay, so our option D is equivalent to the function that they stated, so D is the correct answer. Okay. All right, so the next question reads, if A1 is an arithmetic sequence and B1 is an arithmetic sequence, show that the addition of these two sequences is also an arithmetic sequence. Okay, so first of all, I'm going to state what an arithmetic sequence is. Arithmetic sequence is arithmetic. Yeah. So arithmetic series is basically a sequence of numbers that follows a pattern. Okay, so a sequence of numbers is basically S1, S2, S3, and each of the terms in the sequence are related to another one, to the previous one and to the first term. And the relation that an arithmetic sequence has is that each term of the sequence, the next term of that sequence is just the previous term plus a common difference, or d. Okay, so if we had our arithmetic sequence s1, s2, s3, s4, dot, 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 sn, right? Then if we were to think about it as an arithmetic sequence, we have s1, then we have s1 plus common difference d to be s2, s2 plus common difference d is equal to s3, and so on and so forth. Okay, so the nth term in the arithmetic sequence is going to be sn minus 1 plus d. Okay, so another way that we can describe an arithmetic sequence is if the difference between the consecutive terms are the same. Okay, so what does that mean is that, let's say that in an arithmetic sequence, the difference between the second term and the first term is d, but that's also equal to the difference between the third term and the second term. And if we want to extrapolate further, that's also equal to the difference between the nth term and the nth minus 1 term. Okay, so that's another way that we can describe an arithmetic sequence. That the difference between two consecutive terms, so Sn and Sn minus 1, is equal to the common difference. So all the differences between consecutive terms is going to equal the common difference. Okay, so now that we have described what an arithmetic sequence is, we can now attempt to prove that the sum of two arithmetic sequences is also an arithmetic sequence. Okay. So basically, how we're going to solve this is that we want to show that a1 plus b1, that the consecutive terms within the sequence has the same common difference. Okay, so first of all, we know that a1 is an arithmetic sequence, right, stated by our question here. So that means that a1, a2, a3, dot, 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 an. Okay, that means that according to our definition here, the nth term of our sequence minus the n minus 1 term is equal to our common difference. Okay. Now, same thing with b1. All right, our sequence b1 with b1, b2, b3, dot, 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 to bn. The difference between the bnth term and the bn minus 1 term is also equal to, let's say, a different common difference, which is, I guess, e. Okay? So these are two known facts about this, okay? Now, let's consider the sequence of a1 plus b1, right? So what is that going to be? So the sequence of a1 plus b1 is going to be a1 plus b1 as our first term, a2 plus b2 as our second term, a3 plus b3, and dot, 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 an plus bn. Okay, so we need to show that the difference between these consecutive terms is going to have a common difference. Okay. All right. So let's first think about the difference between our first two terms, right? So a2 plus b2 and a1 plus b1. Okay. So if we were to think about the difference between a2 plus b2 and a1 and b1, what would we get here? Okay. Well, we could rearrange this, right? So if we were to break it out of the brackets, we would have a2 plus b2 minus a1 minus b1, right? And we could rearrange this in a different manner, right? We could rearrange this to be a2 minus a1 plus b2 minus b1, okay? And according to our sequences here, right, a2 minus a1 is going to equal to d, and b2 minus b1 is going to equal e. Okay? So this is the common difference between the first two terms, right? So now we have to show that the common difference between the next two terms is the same, and so on and so forth, and so on and so forth. Okay? So let's check a3 plus b3 minus a2 plus b2. Okay? So if we do this for the next two consecutive terms, if we rearrange it again, right? So we can say this, if we break through the brackets, we have a3 plus b3 minus a2 minus b2. And if we rearrange it, we get a3 minus a2.
3 plus 33 minus 18.
Sorry, that's my series. Okay, a3 minus a2 plus b3 minus b2. Okay, so a3 minus a2 is again d, and b3 minus b2 is again e. So the third term and the second term, the difference between them has the same common difference as the difference between the second term and the first term. Let's check about this in general, right? What about if we check it in general? So let's have an nth term, right? Let's say what's the difference between the nth term of our sum of the series sequences, right? And the nth minus 1 term, right? Okay. So if we break through these brackets again, I'm not going to write it out too much. I'm just going to skip to the third step here. So we have an minus 1, right? Plus bn minus bn n minus 1's term, okay? So here, if we can look at our sequences here, they have the same common difference again, right? an minus 1 is d, and the common difference for bn minus 1 is e. So we have proven that in general, the common difference of our sum of the sequences is equal to d plus e, and since it is consistent across all the terms, we have shown that the sequence of a1 plus b1 is also an arithmetic sequence. So therefore, a1 plus b1 is an arithmetic sequence. Okay. So whenever you're trying to prove any of these kind of questions where it tells us to prove, you always want to try to find the general case, right? Because here, these are specific cases, right? And there might be sometimes a specific case that might not follow this rule, right? But if you solve for the general case, and the general case gives you a consistent answer, then you know that your proof is correct. And in this case, we solved the general case, and we found the common difference for the sequence of a1 plus b1, which is d plus e. Okay? So this solution is correct. Good work. And the last thing I'm going to touch on is that there's multiple ways of proving this kind of question here. And this is just one way that we can prove it. So I guess the challenge for you guys is that think of another way that you can prove that the sequence of arithmetic, or the sum of the arithmetic sequences is also an arithmetic sequence, okay? But anyway, moving on to the next question. Next question reads, the product of two consecutive negative integers is 600. What is the value of the lesser integer? So when I'm thinking about lesser integer, I'm thinking about the integer that is closer to 0 in terms of negatives, okay? So first of all, they give us a statement here, okay? So let A and B be two consecutive negative integers. This means that A is equal to B minus 1, right? So this is what it means that A and B are two consecutive negative integers. B is more negative than A, but they're consecutive to each other, okay? So the second statement that they gave us is that the product of these two is equal to 600, okay? So this is the first statement, and this is the second statement. This is the first statement, and this is the second statement. Okay, so given these two statements, they want us to find the value of the lesser integer. In this case, the integer that is closer to 0 or less negative. Okay. So the first thing that we're going to do is that we're going to plug A into our second equation. So plug A equals B minus 1 into 2. Okay, so that means this is going to turn to B minus 1 times b equal to 600. Okay, so now we're going to expand this. We have b squared minus b equals 600, and we're going to move 600 to the left-hand side. So we have b squared minus b minus 600. Okay, so now we have to solve this quadratic function. We have to find the zeros, or the solutions to the quadratic function, to find the two negative consecutive integers. Okay, so in this case, the junior tutor used the quadratic formula, so I will do the same. So the quadratic formula is, as stated again, x equals negative b plus or minus b squared minus 4ac divided by 2a, where a, b, and c are the coefficients of our quadratic function, so a, b, and c. Okay, so using this quadratic formula, we have negative times negative 1 plus or minus b squared, so negative 1 squared, minus 4 times a, which is 4 times 1, times c, which is 600, divided by 2 times 1. Okay, so this is equal to 1 plus or minus 1 minus 400, 4 times 600, which is 2400, and that would equal to 2401 divided by. Okay, so it so happened that 2401 or 2401 is actually a perfect square, and the perfect square is 49. So it's going to be 1 plus or minus 49 divided by 2, and x is equal to, in this case, 25 or negative 24. Okay. So now that we have found the zeros that solve our quadratic function, we need to put it into context of our question here. They're looking for two consecutive negative integers. And in our solutions here, we see here that one of our answers is a positive. So since x cannot be positive, x is equal to negative 24, or b is equal to negative 24, sorry, I should say that. So b is equal to negative 24. And therefore, a is equal to negative 25. Okay, so our lesser integer is negative 24. Our lesser integer is negative 24. Okay, so that's how you solve this question. This solution is correct. Good job. All right, moving along. All right, the next question asks us to find the vertex of a quadratic function. Okay, so first of all, we have to define what the vertex of a quadratic function is. So our quadratic function is basically a polynomial function with the leading term having a degree of 2. So the standard form of a quadratic function is ax squared plus bx plus c, right? So there's 3 terms to this, and the leading term of our function has the degree of 2. Okay, so this is what we call a quadratic function, and is a subtype of our polynomial functions. Okay, so if you were to graph a quadratic function, what you would get is what we call a parabola. Let me make the axes black. So given our axes here, a parabola takes the shape of a U, and there's 2 different orientations of our parabolas. Okay, there's the upside down U shape and the normal U shape, and the vertex is dependent on which orientation this graph takes, right? So if it is a normal U-shaped, the vertex is going to be the minimum of our quadratic function, and if it is an upside down U-shape, the vertex is going to take the maximum. So these are both what we call the vertex, okay? So vertex either can be max or min. Okay, so there are basically 2 ways of finding the vertex of a quadratic function. The first way is that I guess there's also technically 3. The first way is that you graph it and you visually identify where the vertex is on the parabola itself. The second way is that you use this formula for the vertex, which we will be using this in this solution. And this third way is to actually calculate the derivative of the quadratic function and find the critical point of that quadratic function, and that critical point will be your vertex, basically. So those are the three, I guess, possible methods of finding the vertex of a quadratic function. I'm sure there are more niche methods, but these are the three most popular methods. Okay, and the last thing that I want to describe before I jump into this question or into the formula on how to calculate the vertex of a quadratic function is that the orientation of our parabolas is dictated by the leading coefficient. So if the leading coefficient has a sign that is negative, we would have a downward U facing parabola. Well, if the sign of the coefficient was positive, then we have an upward facing parabola. And that will dictate whether we have a maximum or a minimum. So let me just write that here. So the upward one has a coefficient of positive, and the downward one has a negative coefficient. Okay? So now let's jump into the formula here. So, given a quadratic function of standard form ax squared plus bx plus c, there is a formula to calculate the x coordinate of the vertex. And the formula is as such. So x vertex, that's what I'm going to name the formula, is equal to minus b, so negative coefficient of b divided by 2a. So if you calculate this, you have found the x coordinate of your vertex. And after that, you can plug in your x vertex into your function. So let's say this is f of x. So to find the y coordinate of your vertex, you just calculate f of x vertex. Okay, and that will be equal to x of x vertex squared plus b times x vertex plus c. Okay. All right. So we're going to use this formula on an example. Okay. So our example here is x squared plus xx plus 4. Okay. So x squared plus xx plus 4. So first we identify our coefficients. So this is a, b, and c. Now we're going to use the formula. So x vertex is equal to negative b divided by 2a, and that's equal to negative 6 divided by 2. So here we know that the x coordinate of our vertex is negative 3, and finally we're going to plug it into our function here. So f of negative 3 is equal to 9, or I should write it this first, negative 3 squared plus 6 times negative 3 plus 4. And that's equal to 9 minus 18 plus 4, and that would equal to negative 5. Okay, so therefore our vertex is negative 3, negative 5. And even though we calculated this, we don't know if it's a max or minimum, right? And that's where I told you guys to evaluate your coefficient, your leading coefficient, right? So our leading coefficient in this case is positive, so we know it's an upward facing parabola. So that means that this is a minimum. This vertex is minimum. Okay? All right. So I would say my final note is that you guys can explore the different methods of calculating the vertex and find which one is the most comfortable to use for you. But I believe that using this formula is the easiest method of finding your vertex. Okay, so this solution is correct. Nice job. Cool. All right. All right, so the next question asks us to do a long division and to find the first term of the quotient for this division problem. So I've previously done long division in the past, and it's very similar to normal division. But in this case, instead of having numbers on both sides for your dividend and your divisor, we have a polynomial and a divisor that's a factor. So the main use of long division is to figure out whether or not your divisor is a factor of your polynomial. And the way that we figure out using this test is that if the remainder of your quotient is 0, then that means that your divisor is a factor of your polynomial. Okay. So first, we're drawing out this long divisional bracket. We put in our polynomial or our dividend. Okay. And we're going to divide it by x plus 2, which is a divisor. Okay. So in regular division, right, you want to try to reduce the dividend within the division bracket, right? So by reducing it, you want to multiply your divisor by certain factors and subtracting it to your number within the divisional bracket. Okay. So in the same way, we're going to do this with I guess polynomials. And in this case, we're going to multiply by variables of x or by constants to get rid of to reduce our polynomial. Okay. And the final thing is that in the same way where you drag down digits in normal division, we're also going to be dragging down terms in this division. And I'll get into that a little bit more. Okay. So x plus 2, x cubed minus 1 divided by x. Okay, x cubed minus 1 divided by x plus 2. Okay. So the first thing that we want to do is we want to get rid of this x cubed. So we're going to multiply our divisor by x squared. Okay, so we multiply our divisor by x squared. What do we get? So x squared times x plus 2 is going to be x cubed plus 2x squared. Okay. So if we subtract this, what do we get? We get 0. But these two things don't subtract. So we get 2x squared and minus 1. Okay. And this is also minus negative 2x squared. Okay. So now we want to get rid of this negative 2x squared, right? So we're going to multiply our divisor by positive 2x. Okay. So we multiply our divisor by positive 2x, or negative 2x, sorry. We get negative 2x squared minus 4x. Okay, and if we subtract these together, we get 0 here, we get 5x, and 1 is still not reduced, so we have negative 1. Okay. Oh, wait, why did I write 5x? I was supposed to write 4x, sorry. Okay, now we want to get rid of 4x, so we can multiply our divisor by 4. Okay, so we multiply the divisor by 4, we get 4x plus 2, or plus 8. Okay, and we subtract, we get negative 9. Okay, so in the end, we cannot reduce this any further, right? We cannot divide by x, right? That's ridiculous. So our remainder is negative 9. So therefore, x cubed minus 1 is also equal to x plus 2 times x squared minus 2x plus 4 with remainder minus 9 divided by x plus 2. Okay, so this is our remainder, 9 divided by x plus 2. And they're asking us for the first term of our quotient for the following division problem. So the first term of our quotient is x squared. Okay, so that's how you do long division, right? So this solution is correct, and we can move on. Cool. All right, so our final question of the day is asking us to solve each of these inequalities and write the answer in interval notation. Okay, so I'll get into a little bit about what interval notation is in a second, but I'm going to just jump right into solving each of these inequalities. And the purposes of inequalities is to basically they're asking us to find the values of x which make these inequalities true. So each of these statements are true for certain values of x, and we have to find those values of x, okay? All right, so let's first calculate a. And also let me zoom out here and use a bigger brush. Okay. So a is negative 4 is less than 5 minus 3x, and this is always less than or equal to 17. So the general goal for a lot of inequalities is that you want to isolate for your variable. So in this case, we want to isolate for x, which is in between these two inequalities, right? So the first thing we want to do is get rid of 5, right? So we want to subtract all sides by 5. So to get rid of 5, we subtract as such. Okay. And if we simplify, we get negative 9 less than negative 3x less than or equal to 12. Okay. And so another rule that I want to cover before I continue is that whenever you divide or multiply by a negative number, you have to flip your inequality signs. So in this case, we're dividing all sides by negative 3. So we have to flip this inequality sign from less than to greater than, and this one from less than or equal to greater than or equal to. So if I divide by negative 3, we have 3 greater than x. And if we divide 12 by negative 3, we have x is always greater than or equal to negative 4. Okay, so if I were to rewrite this inequality, because right now it looks kind of messy, we have x is always greater than or equal to negative 4 and less than 3. Okay, so this is the first answer to our solution. Okay, so they ask us to write this in interval notation. Okay, so what it means by interval notation is in this notation. Okay, so if we had, I guess, x is less than a and less than b, interval notation would be x belongs to ba, right? So this is usually by notation a coordinate system, but in this case, this is what we call interval notation. And the type of bracket matters here, since if x is less than or equal to a and greater than or equal to b, then x belongs to closed bracket b, a closed bracket, right? So these closed bracket means that it includes b and a, while these rounded brackets means that it does not include b and a, right? And the way that we read it is x belongs to, or x is greater than b but less than a. So this is what interval notation means. So in this case here, interval notation would be x belongs to negative 4. So negative 4 has a closed bracket because the interval includes negative 4, but always has to be less than 3. And this is a rounded bracket. Okay. All right, so moving along to the next inequality, we have that b asks us to find the values of x, which makes this inequality true. X squared is always less than 2x plus 8. Okay, so like in the general rule, we want to isolate for x. Okay, so we will move all our x's to one side. So to do that, we move 2x to the other side, and we have this. Okay, so this is still kind of hard to calculate, right? Because we need to find the values of x, which will make it less than 8. So why don't we make the values of x, which makes this less than 0? So we move the 8 to the left-hand side, and we have x squared minus 2x minus 8 is less than 0. And lo and behold, we just have to find the zeros of our function and then evaluate which intervals make our function less than 0. Okay. So if we were to factor this using the cross multiplication method, we have x minus 4 times x plus 2 is less than 0. Okay, so now we want to test what values of x would make this inequality less than 0. So the first interval to check if x is less than negative 4. Okay, so if x is less than negative 4, let's say x is equal to negative 5, we would have a negative number here and a negative number here that would equal to a positive number. So we can't have that. Okay. So the next one we want to check. Okay, so we know that if x is less than negative 4, that translates to x greater than 0. So we don't want that. What if x is between negative 2 and 4? Okay, if x is between negative 2 and 4, so x is between negative 2 and 4. Also, I meant to write negative 2 here. Okay. What do we get? Okay, so if x is between negative 2 and 4, let's say negative 1, right? This would be negative, right? So negative 1, x equals negative 1 would be negative 5 times negative, or 1, right? So that will be x less than 0. So this is the interval where x is less than 0. Finally, the last interval that we want to check is x is between, is greater than 4. Okay, so if x is greater than 4, let's say 5, then we have a positive number in both, right? So 5 minus 1 is 1, and 5 plus 2 is 7. So 7 is not less than 0. 7 is greater than 0. So x is greater than 0. So we have found our interval here. So therefore, x belongs to -2 and 4. That's the interval notation for B. Okay. So let's look at C. All right. So C, they give us a factored form of our polynomial, or our quadratic function, or actually it's a polynomial, which is they're asking for the values of x, which would make this expression greater than 0. Okay, so we have a few zeros that we need to check here. So x equals 0, 1, and -2. So when x equals 0, 1, and -2 is equal to 0, right? But we want to make sure that we want to check in between each of these zeros to see whether or not it is positive or negative. Okay, so the first interval that we want to check is if x is less than -2. So if x is less than -2, what do we get? Negative, negative, uh, negative. So that means that x is less than 0, right? Because if x is equal to -3, -3 times -4 times -1 is going to be a negative number. Okay. So next thing that we want to check is if x is between -2 and 0. Okay. So let's say x is equal to -1. If x is equal to -1, we have negative, negative, positive. So x is greater than 0. So x is a positive number. Next interval that we want to check is that if x is between 0 and 1, so let's say half. If x equals half, then it's half times negative half, so negative times positive, so x is less than 0. And finally, we want to check if x is greater than 1, and it's going to be positive, positive, positive. So x is greater than 0. So therefore, x belongs to -2 and 0, or 1 and infinity. So this U-shape tells us that there are two different intervals that x is positive, that makes this expression positive, which is -2 and 0 and 1 and infinity. It's either or. It cannot be both. Okay. So let's talk about D. So D is asking us for the absolute value of x minus 4 is less than 3. Okay. So there's a rule about absolute values which states that the absolute value of a less than, let's say, x means that this is the equivalent to that, which states that we want to find a less than x and also greater than -x. Okay, so using this property in mind, we can break up our absolute value bracket to be x minus 4 greater than 3, or less than 3 and greater than -3. And this becomes a very easy inequality for us to solve because we just isolate for x. We know that x has to be less than 7 and greater than 1, and therefore our interval is x belongs to 1 and 7. Okay, so this is a property about absolute functions that you guys need to know, that the absolute function of a, or absolute value of a when less than x, is equivalent to saying a greater than -x and less than x. Okay. Finally, we are given e. Okay. So now we're given a rational function, and we want to evaluate whether when it's less than or equal to 1. Okay. So in the same method for rational functions, or I guess quadratic functions, we want to empty the right-hand side to make it equal to 0. Now it'll make it a lot easier for us to solve this inequality. So we're going to move this 1 to the other side. So 2x minus 3 divided by x plus 1 minus 1 is less than or equal to 0, right? So now we're going to include this all under one denominator. So we're going to have 2x minus 3 minus x plus 1 divided by x plus 1 is less than or equal to 0. And we have here x minus 4 divided by x plus 1. Okay. So now we need to evaluate what values of x makes this expression equal to 0. Or in this case, what values of x makes this expression equal to 0 or undefined, right? And from that, we need to evaluate in those intervals where the value or the expression is less than or equal to 0. Okay? So the values of interest here is x equal to 4 and x equal to -1. So x equal to 4 makes this expression equal to 0 because x equals to 4 makes the numerator equal to 0, and 0 divided by anything is equal to 0. And x equals negative 1 is also a point of interest here, because when x equals negative 1, our function is undefined here, and that gives us reason to believe that there's intervals and between that. Okay. So given that in mind, now we need to test our intervals here. So let's say that x is less than negative 1, right? So if x is less than negative 1, we have that the denominator is going to be negative, and our numerator is going to be positive, or negative 2. So that means that x is going to be greater than 0. Okay. All right, so what if x is between negative 1 and 4, right? What happens here? So if x is between negative 1 and 4, let's say 3, then this will be a negative number and this would be a positive number. So that means that we have x to be less than or equal to 0. And we want to include 4 here because we also want to find the values of x, which makes this expression equal to 0. Okay. Finally, we want to test the last one, which is x greater than 4. And if x is greater than 4, we have a positive number and a positive number on the numerator and the positive number on the denominator. So x is greater than 0. So therefore, x belongs to negative 1 and 4. Okay. So all these solutions are correct, and the solution is correct. Nice. Okay. All right, so that wraps up my lesson today. I covered 10 questions related to functions, algebra, and also long division, and also related to the quadratic formula. So if you have any other questions or concerns with your math homework or your chemistry homework, calculus homework, please submit them to OneClass and we'll get them done as soon as possible. Other than that, wish you guys a good night. Bye, guys.